the branch one office router, we taking commands like that IP address assigning and no shutdown. After that, clock rate with bandwidth and encapsulation. In other router like branch 2 office, when we configuring that, what is the command for clock rate? Like for
See, clock rate is two methods, right? Two type of devices. One is DCE and DTE. The port which
DTE,
is
yes sir,
DCE, for DC
yes sir,
interface only you need to configure the clock rate. In DTE
clock rate, yes sir.
not required, ignore it.
No, yes sir, okay, clear sir, clear. Okay sir, thank you sir.
Yeah. Aliaskar,
Yes, sir.
any doubts?
No doubts. No, sir. No doubts.
Okay. Atul.
No doubt, sir. Clear.
Okay. Murphy, any doubts you have from day one to till today?
Let's move on, sir.
Okay.
Yes, sir.
Shrikant.
So I have one doubt.
Yeah, please.
Like yesterday we discussed that exit point is the serial port.
Correct.
Before serial port, Ethernet port also available. So why it's not Ethernet port for the exit point?
Exit is not Ethernet port, Shrikant.
Okay. Okay.
See how your branch is connected. This is your router. Ethernet port. From Ethernet port, traffic is not going to outside. Ethernet port is connected to your local LAN. Ethernet is connected to LAN, right? Here, one of the user is connected. So user data traffic is being generated. Data traffic come to Ethernet. From Ethernet, it can't go to outside. So from Ethernet, it has to switch the traffic to serial port, WAN port. So this is your WAN port, serial 0/0. This is exit point. We have multiple exit point, serial 0, serial 1, serial 2. We have multiple exit points. Then we have to decide which is the best path, best exit point, and configure it. Okay?
Okay. Okay.
Yeah. Tarun? Any doubts, Tarun? Famiva? Any doubts?
Sir.
Perfect. It seems you don't have any doubts, right? Then I have few doubts. Can I ask you people?
Yes, sir.
Sure?
Yes, sir.
Oh, okay. Then try to understand my question, what is exactly I'm trying to asking you. So there is one scenario, please. Office ABC. In Office ABC, have different departments, guys. Like a sales department. A sales department having 50 hosts, 50 devices in sales department.
Okay.
When for HR department, there are 50 computers. Marketing department, 50 computers. IT department, 50 computers. So here my question is, total how many devices in Office ABC? For all
200,
departments.
200, sir.
200 hosts.
No, 200 only host, except
Yeah. So for 200 hosts, which class IP address do you recommend to use?
class C.
Class A, or class B or class C?
Class C.
Class C,
Class
sir.
C. Because if we use class A for network, for each network of class A, there are 16,777,214 IPs are available, but the
Yes.
requirement is only 200. So if we use class A network, out of 16,777,777, if we use only 200, remaining all IPs are wastage. Agree?
Yes, sir.
Yes.
So class A is not recommended at all. Even for class B also, per network, there are 65,534 IPs are available. Out of these many large, we use only 200. Remaining IPs are waste. So class B is not
Yes.
recommended. And best one is what?
Class C.
Class C, 254 IPs. Agree?
Yes, sir.
Yes.
Okay. Then give me class C IP address.
192.168 1.1.
1.0 can we use?
No.
No.
1.255 can we use?
No.
No.
Okay. So let me start with 192.168
No.
1.1 to 192.168
50.
1.50 for which department?
Sales.
Sales. Sales
Sales.
department.
For HR department, 192.168 1.51
51.
to 1.100.
100.
100.
1.100. For marketing
HR.
department, 101
101
to
to
150.
150. Like for ID department,
151.
200.
151 to 200.
151 to
200.
200. Got it?
Right.
Yes.
So like this, I have assigned for each department. So here, the question is, now sales department, HR department, marketing department, IT department, all departments, all 200 devices, will they communicate to each other?
Yes.
Yes or no?
Yes, sir.
Yes. Yes. Yes.
Yes. Why they can communicate?
Same class.
Class C IP address.
Same class, sir. Belongs to same class and network bit host bits are same.
Same network, right?
Yes.
Because of not same class. Because
Same
of
network,
same
sir.
Same
network
network.
portions.
Okay. Same
Yeah.
network.
All are comes in the same network. Okay. But my requirement is sales department should not communicate with HR. HR should not communicate with marketing. Marketing should not communicate with IT. Like inter-department communication should not be there. What is your solution?
But we need to use same IP, sir, right? Same class IP, same network IPs.
Yes. Whatever. Requirement is what? Like sales department, HR department, inter-department communication should not be there. So currently all devices can communicate because all are in same network.
Yes, sir.
But my requirement should not communicate actually. Then what is the answer? What solution?
Okay. So we can make routing policy.
Viva. What is the solution here? Tarun, Srikanth, Salma.
Can we use routing protocols here?
See, routing protocols to enable communication from one LAN to another LAN.
Sir, VLAN.
No. See, first understand the scenario. There is some simple answer is simple actually. See, now if I assign IP address like this, all devices are communicating, right?
Yes, sir.
Why?
Say, network is same. We can use different network ports.
Because all devices are in same network. Then why it's communicating? But your requirement is what? Should not communicate. Then answer is what? Solution is what?
Network bit we can use 1, 2, 3. Like,
Like change the network portion.
yes.
Change the next
Make them into different networks.
Yes.
Agree?
Yes, sir. Right.
So based on a requirement, we can make them into different networks now.
Yes.
Then why you're thinking much? Simple. Sales department, it will be 1.1 to 1.50. HR department,
2.1.
2.1,
2.1
2.1,
to
and
2.50.
2.50.
Like this. HR department,
3.1.
3.1 to
sorry,
3.50.
marking department, 3.1 to 3.50. IT department,
4.1 to
4.1 to
4.50.
4.50.
4.1 to 4.50. Now, so sales department, HR, marketing, IT, will they communicate each other?
No.
No.
No, sir.
No. Why?
They are not on the same.
It's all different.
Because they are in different networks.
Yes,
Is my
sir.
condition, is my requirement is satisfied or not?
Yes, sir.
Yes.
Yes.
Yes, sir.
My requirement is should not communicate and we make them into different network and they don't communicate. So my requirement is satisfied actually, but there is a problem. My requirement is okay, but problem is for each network of class C, how many IP addresses are available?
254.
254 is available. Out of 254, how many IPs are used?
50 only.
1.1 to 1.50. Remaining how many IPs are being wasted for sales department?
204.
200 plus. For HR department, how many IPs are wasted?
200.
200 plus.
200 plus.
800.
For marketing department,
200 plus.
for IT department,
200 plus.
so total how many IPs are wasted?
More than 800.
800 plus. Agree?
Yes.
So for 4 departments, 800 plus IPs are being wasted. So from IPv4, out of 4.3 billion IP addresses, we are not using class E because it's reserved for what? R&D. And class D IP is also not using for LAN and WAN. We are
No,
using
class
only class A, class B, class C.
Let's see.
From ABC class also, zero network is minus for global ID. 127 network is minus for loopback ID. Network IDs are minus, broadcast IDs are minus. So remaining IP addresses also, if we waste like this 800 plus IP addresses for 4 departments in one company, then how many companies and how many departments and how much IP wastage will be there?
Too much.
Too much. So if we wastage like this, then how we can survive with IPv4 is not possible.
We can go.
In 90s, in 99, early of 1990 itself, like we are running out of IPv4, we required more number of IP addresses. IPv6 has been introduced. But till now, we can survive with IPv4 only. Till today, we are getting internet access with IPv4. Agree?
Yes, sir.
So how it can be possible? Only one alternate option we have actually. Alternate mechanism was developed actually.
Yes, sir.
Simple logic is these wastage we need to be avoided, guys. That's all. So whatever IP wastage is happening, this wastage need to be minimized. You need to reduce this wastage of IP address. If you reduce the wastage of IP address, then we can survive with IPv4 for next generation also. But how? How to minimize? A requirement is we need a 4 different networks, right? Means all departments should not communicate each other. For we require 4 different networks. So instead of taking 1 dot network, 2 dot network, 3 dot network, 4 dot network, 4 different networks, 4 different apples. Instead of this taking 4 different networks, you can take only one network, 192.168, 1.0 or 2.0, any one network, and we can divide into 4 parts.
Yes, sir. Subnetting.
So dividing a one network into multiple different networks. This process we call what? Subnetting. So subnetting is a like alternate and option. Alternate technology was developed to survive with IPv4. So till today, we are using IPv4 means because of what?
Submitting.
Yes, sir.
Subnetting. So as per your understanding, you tell me what is subnetting?
Sir, it's
Division of IP address.
Huh?
Division of IP address, sir.
Division of IP address. Okay. Next.
to minimize the wastage of IPs.
That is purpose of subnetting, Tatul.
Yes.
What is subnetting?
Sir, divide the
Yes.
big network into a small portion.
Right. Simple. So dividing one network into multiple networks.
That's
So dividing one parent network, creating multiple independent network from one single parent network actually, right?
right, sir.
So subnetting means creating multiple independent network from a single network. Same example, this is Apple. How many pieces you can cut it?
As per our requirement.
As per our requirement. You want to make it into 2 pieces? Yes, you can make it into 2 pieces. Want to make it into 4? Like you want to make it 10, right?
Yes, sir.
As per our requirement, we can create multiple pieces, right? Similarly,
Yes, sir.
one from one network, based on our requirement, we can create multiple different networks. But how can it come technically possible is converting host bits into network bits.
Yes, sir.
Means converting zeros into ones.
Once
Basically, for class A, first octet is what?
network,
Network, host, host,
host,
host. But our example, you're taking class C network. Here, network,
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 and host.
network, host, right?
Yes, sir.
So host means zeros. One,
Zero.
2, 3, 4, 5, 6, 7, 8. 8 bits, 8 zeros.
Yes, sir.
So what we need to do? Convert host bits into what?
Network bit.
Network bits. Like how many bits we need to convert depends upon our requirement. Based on our requirement, we can convert 1 bit or 2 bits or 3 bits or 4 bits based on requirement. We can convert it actually.
Yes, sir.
So subnetting can be performed the 2 ways: fixed
Yes.
length subnet mask and variable length subnet mask, FLSM and VLSM.
Yes, sir.
Subnetting can be done based on requirement. So this is very important point actually. Entire subnetting can be done based on what?
Requirements.
What requirement? Based upon number of networks required, number of hosts required, Cisco slash notation required. So this subnetting is very useful for service providers and large companies. Because service providers, we need to provide IP addresses for customers. For each customer, they have to provide. They can't provide one network for each customer now.
Yes.
So they'll take one network and divide into multiple parts, and each part for each customer. Like one network is divided into 100 parts. So I mean, how many customers they can provide?
Hundreds.
100 customers. If it is not divided, then one network he can able to give for how many customers?
Only.
Only one customer. Not possible to survive. Got it?
Yes,
So
sir.
what service providers will do, they'll take one network and customize. They divide it into multiple networks. Each network go to one customer actually. Well, if you're following me, Tomiwa,
Yes, sir.
Yes, sir.
getting my point?
Yes, sir.
Murphy. Okay.
Yes, sir.
Rajkumar, Salma, Frin.
Yes, sir.
Yeah. Sham, Srikant, Tarun.
Yes, sir.
Right. Okay. So now task is we need to use one network and divide into multiple parts. Correct? Let us say this is one network. For example, 192, 168,
Hmm.
1.0 network. 192, 168, 1.255. 254, 255 dot 255, 255.0. So what is this? 192.168.1.0, what we call this is?
Network ID.
1.255,
Broadcast ID.
254,
Usable IP.
usable IP, or we can call valid IP address.
Validate.
What is this 255, 255,
Subnet
255.0?
mask.
Subnet
Subnet
mask.
mask.
Remember in IPv4 sessions, I clearly explained about for any IP address, there must be 4 parameters,
Yes, sir.
correct?
Yes, sir.
Network ID, broadcast ID, valid IP address, and subnet mask.
Subnet mask.
Yes. So this is what we call one parent network. This is one network actually, correct?
Yes, sir.
So from this network, we can create multiple different networks. Using this one parent network, we can create multiple different network based on our requirement. Agree?
Agreed, sir.
Based on our example, Office ABC requirement is what? How many departments are available? How many
Four
networks
departments.
Office ABC required?
50 each.
4.
4, not computers. 4 departments. We need a 4 different networks, right?
Yes. For
So means we'll divide this is into four parts. Agree?
Yes, sir.
Hmm.
Yeah. Happy birthday. Okay. So from one network, we can create into multiple different networks now, right? So from this network, we can create multiple different networks based on our requirement. Now our requirement is 4 departments. So let us make divide into 4 parts. Have divided this one network into 4 different networks, right? Then each block, each part we called subnetwork. Now it is not a network actually. Now we can't call it as a network, right? Because before dividing, then we call it as a network. But now it is what?
subnet.
Subnetwork. In short form, we call subnet. In short form, we call this what? Subnet. Means one network is divided into how many subnets?
4.
4.
4 subnets. Then each subnet must have the 4 parameters.
Yes, sir. Different
What are
subnet.
the 4 parameters?
IDs, broadcast.
Network ID, broadcast ID, usable
Broadcast
IP
ID.
address, and subnet mask. So that network ID, broadcast ID, usable IP address, subnet mask will be changed.
Yes, sir.
If it is not divided, 1.0 is the network ID, 1.255 is the broadcast ID, 254 are usable IP addresses, 255, 255, 255 is the subnet mask. But is now it is divided now.
Yes.
Parameters will be changed. So let us calculate. I'm starting point number 1, number of networks requirement. Okay. Number of networks
Four.
requirement. For number of networks requirement, formula will be 2 power n greater than or equal to requirement. So remember this formula. 2 power n greater than equal to requirement actually. Clear?
Okay.
So let us take 2 power n values. Two power 2, 4,
4, 8,
8,
16, 32, 64, 128.
128. Our base example we are taking from 1.0. Office ABC requirement, how many networks?
4.
4. Now implement the formula as it is.
Satisfying, sir.
2 power n greater than or equal to requirement is 4. So what n value will be satisfied?
2.
2.
2. 2 power 2. So what is the 2 power 2 value?
4.
What is 4?
Number of networks.
We can't call it as the networks now. We call it is what? Subnetwork.
Subnet.
Subnet, yes. Subnet.
Net.
Call 4 subnets. Right?
Yes.
Done. The next point is the class C. So for class C, what is the default mask?
255, 255, 255.0.
Agree?
Yes, sir.
Convert to decimal language. Binary. Right? This is in binary.
1, 1, 1, 1, 1, 1, 8 times 1. Last bit is 0.
24 ones, 8 zeros.
Right, sir.
2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8.
Not 0.
1, 2, 3, 4, 5, 6, 7, 8. Correct?
Yes.
Yes. What is subnetting? Converting host bits into
Network bits.
means converting zeros into ones. So
Yes,
what
sir.
are the host bits we have? These zeros we need to convert into ones actually, right?
Yes, sir.
But how many bits we need to convert? It depends always your power value.
2.
Power value is 2, then convert 2 bits. If power value is 5, convert 5 bits. If power value is 3, convert 3 bits. Now what is power value? 2. Converts first 2 bits.
First 2 bits.
What is the first bit value? 128.
128.
64. So now we got one new mask actually, right?
Yes. Subnet mask.
255 dot 255 dot 255 dot
190.
128 plus 64.
190.
192.
192.
192. Before subnetting, what is the mask we have? This mask we called
Default.
DSM, default subnet mask.
Yes.
After subnetting, we got one more mask. This mask we called CSM, customized subnet mask. If it is not subnetted, then we call it is a DSM, default subnet mask. If it is subnetted, we call it is
Customize.
CSM, customized subnet mask. Done?
Yes, sir.
Okay. And next step is 4 subnets are available. For each subnet, how many IPs are available and how many usable IPs are available? That also we should know now.
Mhm.
Simple.
55 plus 255.
2 power number of host bits base minus 2. 2 power number of host bits. How many host bits are available? How many
6.
host bits are left? 6 host bits. So 2 power 6 minus 2. What is 2 power 6 value?
64.
Minus 2.
50.
What is 62?
62, yeah.
Number of
62 is what?
hosts.
Number of hosts are 64.
E-
62
Usable app.
usable address.
Usable app. IP. Yes, sir.
64 available. How many can use, Atul?
Yes, sir. -2. 2 IP.
Yeah. So minus 2. So 62 valid
IPs.
host
IP.
for each 62 valid host for each what? For each?
For this customized subnet mask, sir.
For each subnetwork. For each subnet, how many usable IP address? 62. So how many subnets are available? 4 subnets. For each subnet, 62 usable IP addresses are available actually. So let us try to write network ID and broadcast ID. First subnet range, second subnet range, third subnet range, that. Very simple. A base network is 192.168.1.0. What is second subnet range? Third subnet, fourth subnet, we can easily identify. Simple logic here. How many bits we converted?
2 bits.
Out of 2 bits, which one is the least converted bit?
64, sir.
128, 64. So which is the least converted bit?
64, sir.
64. The least converted bit is a magic number. Remember always, least converted bit is a magic number actually. 64. Then you can write 192.168.1.64. Next,
Mm.
192.168.1 dot plus 64.
128.
So you keep on adding 64, 64 with what is the magic number, least converted bit? You add on 64, 64 multiple times up until you got invalid IP address actually. 192.168, 1 dot plus 64. 192. 192.168.1 dot plus 64.
255. 56.
256.
Invalid.
Is it valid?
Invalid, sir.
No,
Stop here. So very simple broadcast IDs. You just write what IP before this IP will come. Before
255.
256, what is the number?
255.
Before 192,
192.
before 128, before 64, you can write it actually. So 192.168.1 dot 255. Here 192.168, 1 dot before 192, 191.
191.
Before 128,
27.
27.
1 dot 127. Before
127.
64,
63.
63. 190.168.1.63.
256 is invalid, remove it. Then we have 4 subnets.
Yes, sir.
Is the first subnet range, second subnet range, third subnet range, and fourth subnet range. These all are network IDs. These all are what?
Network
Broadcast
IDs.
IDs. So we can dedicatedly assign, we can ask to sales department, you use from 1.0 to 1.63 IP addresses. This is for sales department. So sales department can use 1.0?
Yes.
No. No,
No,
1.0 can't
network.
use. No.
Network ID.
1.63 IP address can they use?
Yes.
No.
No.
1.63 also cannot be used now. This is broadcast ID.
Broadcast.
It's broadcast ID. Yes.
In between IPs they can use 1.1 to 1.62 IPs. 62 IPs are available now. Got
Yes,
it?
sir.
Okay, then ask to HR department will start using from 1.65 to 1.126. So HR department can use 1.64.
No.
No, sir.
No.
1.64 can't be used because of network ID.
Yeah.
1.127
Broadcast ID.
broadcaster they can't use. Between 1.65 to 1.127 you can use. So this is for marketing department and this is for IT department. So like I have assigned, now tell me guys, sales, HR, marketing, IT, will they communicate each other?
No, sir.
No, sir.
No. Why?
They are not on the
Different
same.
networks.
Because they are in different?
Networks.
No.
Sub-networks.
Sub
Subnets.
networks.
What
Because
network?
they are in different sub networks, they don't communicate. My requirement is what they should not communicate now. Correct?
Yes.
But how many networks I used? I used only
One network.
One
one
network.
network and my network, my requirement is satisfied. They are not communicating. So we minimize the wastage of IP address. If I use the different networks, how many IPs are wasted?
100.
800 plus.
100 plus.
When if you go for different networks. Since of different networks, we can take only one network. So if you use if you use only one network and divide into multiple parts, you minimize the IP wastage. The same time, our requirement is being satisfied also. Agree?
Excuse me, sir.
Yeah, please.
Sir, can you show again how we got these four subnetworks?
Our subnetworks, see the first step. So first step, second step, third step, fourth step. Where do you have doubt? Tell me.
After third step, sir.
After the fourth step, you have right.
Yes,
I mean, network ID broadcaster ranges. See, total how many IPs are available?
64.
Or how? What is the least converted bit? 64.
64.
So you start from your base network. You start from your base network is 1.0.
Hmm.
So for 1.0 add 64. For 64 add one more 64. For 128 add 64. So you get all these 64, 64, 64 increments of 64 now. Correct?
Yeah. Yes, sir.
And write this for 192 if you add 64 you get 256. Before
Yeah, that is
256 IP is
amazing.
255.
Yes, sir.
Before 192 191. Before
Yes, sir.
128
Got it.
127. Before 64 63. Then you got a range.
Got it, sir.
Yeah. It's clear everyone?
Yes.
Yes, sir.
Okay. So this is one example for number of networks. We'll take one more example for number of host requirement. Number of host requirement. Same formula. Like 2 power h minus 2 greater than or equal to requirement. H indicates host and indicates networks like that. So 2 power h minus 2 greater than or equal to requirement. Okay. Yeah. 192, 168. Let's say now I'm using same example 1.0, but now Office ABC requirement will be host requirement. My requirement is 12 host, 12 IP addresses separately I need actually, not a network. So 12 hosts actually, right guys?
Yes, sir.
Okay, from this network. Let us implement formula. 2 power h minus 2 greater than or equal to requirement is 12. Let me take this power table. Always use this power table for reference purpose. Okay, so what h value will be satisfied for a requirement? A requirement is 12 and it should be 2 power h minus 2. This value should be greater than or should be equal to for our requirement. Can I use 2 power 3?
4, sir.
Four.
No, 2 power 4. So 2 power 4 minus 2, 12. 2 power 4 is
16.
2 power 4 is 16. 16 minus 2. 14. What is 14?
Host.
Valid host per subnet. But what is my requirement?
12.
12.
From 14, can we use 12?
Yes.
Yes.
Yes. But can we use 12 from 10?
No.
No.
No. So that is the formula itself. It should be equal to or should be greater than. If greater than means no problem. From 12, from 14, you can use 12. Right? So we have 14 usable addresses, but our requirement is 12. Like happily from 14, you can use 12 actually. Done. Subnet mask. Default subnet mask will be 255.255.255.0. 1, 2, 3, 4, 5, 6, 7, 8. But in host conversation, in host calculation, number of host bits, we need to convert in like this actually. Even for number of host bits also, we need to convert host bits and network bits. But how many? Depends upon power value. Power value is 4.
Yes.
So leave your 4 host bits, last 4 host bits, and remaining to convert. If power value is 3, then leave 3 host bits and remaining to convert. If power value is 5, then leave 5 host bits and remaining can be you need to convert actually. Like this. If power value is 2, then what we need to do? Just leave 2 host bits and remaining all need to be convert. Got it?
Okay.
As for this example, what is our power value?
4.
4. Leave 4 host bits. Let me convert remaining. 128, 64, 32, 16. What is the mask? Customized mask? 255 dot
255.
255 dot 255 dot 128 plus 64 plus 32 plus 16. It is a 240. It's a CSM. And next step, how many subnets? Say is 2 power n. Means how many network bits are converted?
4.
4.
2 power 4. 16
16. Yeah.
subnets. Network ID, broadcast ID. That is a magic number.
192 to 168.
16.
Magic number is
16.
16. Start from first network. The base network is 1.0. Now increment of what?
16.
16.
16. 1.16. 192, 168, 1 dot plus 16.
32,
192, 168, 1 dot plus 16.
64.
48. Like you keep on adding 16, 16, 16.
Okay.
So at last subnet will be 192, 168, 1 dot 240, and broadcast ID will be 192, 168, 1 dot 255, right? So here 192, 168 plus 16 means it's a 63. 64 you get 63. 192, 168, 1 dot 47. Before 48 is 47. Before 31, sorry, before 32,
31,
31. Before 16,
15.
1 dot 15. So first subnet, second subnet, third subnet, fourth subnet. It is 16th subnet. 16 subnets we have actually. Got it?
Yeah.
This is the network ID and it is a
Okay.
broadcast ID. Yeah. So like this, we can understand number of network requirement and number of host requirement. Okay.
Sir, can you please explain the first formula, like 2 power h minus 2
So our requirement is
equals to
host
2?
based, host requirement. So 2 power h minus 2, y minus 2 network ID and broadcast ID.
Yes, sir.
So this value should be greater than or should be equal to based upon our requirement.
Yes, sir.
So my requirement is 12.
12.
Then this 12 value, it should be greater than for your formula. Our formula is
Yes,
what?
sir.
2 power h.
Yes, sir.
So I use 2 power 4. 16 minus 2, we got 14. From 14, I can use 12 IP address.
Okay, sir. Based upon our requirement, we use the number of host, power host.
Entire subnetting can be done based on a requirement only.
Okay, sir. Okay, sir. Thank you, sir.
It can be networks requirement, it can be host requirement, it can be Cisco slash notation, and the name itself is telling is what based on a requirement. We can customize. That is why I asked you, Atul.
Yes,
Right?
sir.
One apple, how many pieces we can cut it?
As per
4
requirement, sir.
Requirement.
Based on requirement.
is
We
requirement.
can make into 30 pieces also, right? Small pieces.
Yes, sir.
Yes. We
Yeah.
know.
So next point about Cisco slash notation. Now, when you are practicing static routing, in routing table, have you seen /8, /16, /24 values, right?
Yes, sir.
Yeah. You'll get to know what is exactly that. Slash indicates number of
Network.
network bits, number of network bits. That's all. You just remember this important point. Slash indicates what?
Number of network bits.
That's it. Number of network bits. So if I say /16, what does 16 indicates?
Number of network bits.
Number of network bits. If we /8, 8 means what?
Number
8
of
network bits. /24, 24 means
24.
24 network bits. /29, 29 network bits. /12, 12 network bits. /18, 18 network bits. So after slash, what is the value? What is the number that indicates what? Number of network bits. Right?
Yes, sir.
Okay.
Sir, one question, sir.
Mm-hmm.
Sir, please go to previous that How to find that number of host requirement?
1 minute. Yes,
Yeah, right, sir.
number of host requirement.
Exactly first page, sir. That first page.
You're asking about number of host requirement, right?
Yes, sir.
Yeah, this is.
Right, sir. Yeah. So, for this, sir, that subnet network IP we find. So subnet mask will be 240 only, sir, right? For all
Correct.
IPs.
Yeah, for all subnets, submask will be fixed. That is what we call FLSM, fixed length.
Yes, sir.
Subnet mask. Subnet mask is fixed for all subnets. For first subnet, same mask. For second subnet, same mask. For all 16 subnets, same mask.
Okay, right, sir.
Even they don't communicate actually.
Clear, sir.
Like you can understand with this example. C is one computer. C is another computer. Both are connected. For computer 1, IP address 10.0.0.10 I have assigned. What is subnet mask?
55.0.0.0.
For second computer, have assigned IP address 9.0.0.10. What is subnet mask?
Same, sir.
So device 1, device 2, will they communicate?
No.
No. Why?
Different net.
It is 10th floor, it is 9th floor. I mean, it is the 10th network, is the 9th network. Now, both are in different networks, correct?
Yes, sir.
Yes.
But mask is same.
Different.
Yeah. So network portion is different actually. It's not like a mask is same. No, not. The number will be different. No devices actually they implement ANDing method. So by ANDing process, they can come to know both are in different networks.
Clear, sir.
Yeah. Bits means zeros and ones. 0 indicates
Host port.
host. 1 indicates
Network portion.
network bits. In this example, enter this in example. Total number of network bits. How many network bits are available?
0.
0. No network bits, right?
Right, sir.
How many host bits are available?
24.
24 or 32?
32, sir, right.
32. So my requirement is /1 slash notation. What is slash indicates?
Number of network bits.
How many network bits I need?
1 only.
One.
So first bit I make it as a network bit. What is the first bit value?
120.
128.
So 128 dot
0
second
dot
octet
0.0.0.
0 dot third octet
0.
fourth octet.
0.
So /1 you can write like this 128 dot 0 dot 0 dot 0. Correct?
Yes, sir.
/2. /2 indicates
2 network bits means
2 network bits and one more. 128 plus 64. How
90.
much?
192.
192.
192 dot
0 dot
0
0
dot
dot 0
0 dot 0. /3
network
240.
3 bits
3
plus
bit
32
32
224
220.
dot 0 dot 0
dot 0
dot
dot
0
0
/4 4 network bits means 16
16
plus
240.
16
240.
240
40
dot 0 dot 0 dot 0 /5 5 network bits plus 8
8.
248 dot 0 dot 0 dot 0 /6 6 network bits plus 4
252.
dot 0 dot 0 dot 0 slash 7 plus 2
254.
254
4.
dot 0 dot 0 dot 0 slash 8 1
255.
255 dot 0
Dot
dot 0
0 dot
dot
0
0
dot
is a
0.
slash 8. Got it?
Yes, sir.
Slash 9 then.
255.19.
Slash 9 means what?
No, sir.
Invalid, right?
Invalid.
Why invalid, man? What is
Sir, we
slash
can borrow,
indicate?
sir. We can borrow it, sir, right?
No need. See, what is slash 9 indicates?
9 bits, sir.
9 network bits.
Yes, sir.
So slash 8 means 8
Second
network bits. We
octet.
need one more.
Octet.
These all are 8
Octet.
network bits. And take one more here.
Yes, sir. 19.
Okay.
128.
128.
Yes.
So 255 dot
128.
128.0.0 slash 9
Yes, sir.
slash 10
Same way.
64 255 dot
192.
192.0.0. Likewise, slash 16. Tell me slash 16. 16 means what? 16 network bits.
Yes, sir.
For 8 network bits is 255. Then
255
plus 16 bits.
0.0.
Perfect. 255 dot
255 dot
255
0
dot 0 dot 0. For slash 24. 8 plus 8 plus 8. 24 now.
255
255 dot 255 dot
255.
255 dot 255
255
dot
dot
255
255
dot 0.
dot 0.
Similarly, tell me slash 17. 16 we know, right?
Yes, sir. 17.
How many more we required?
255 255.128.
How many more bits are required?
One only.
Only one. So what is the 1 bit value?
128.
128.
128. So 255 dot 255 dot is 16. We
128.
need one more.
128.
128 dot 0 slash 29. 24 we know.
Yes, sir.
29 we need. How many more bits are required?
16 means 16.
24 we know. 29. How many more
Four, sir.
bits we
4,
need?
4. 4.
5.
Oh, 5, yes, sir.
What is 5 slash 5?
3, 4, 5. 140.
248.
48.
248.
So 255 dot 255 dot 255 dot
240.
Yeah.
simple. So by using any slash notation, we can find out the subnet mask. Correct?
Yes, sir.
Even if I have a subnet mask also, we can find out the slash notation. Then tell me 255 dot 255 dot 252.0. Tell me slash notation.
16.
255 means 8.
Yes, sir.
255 means 8.
6.
252.
22,
252 is how many bits?
6.
22
6.
total.
6.
1.
So 16 plus 6
22 total, sir.
slash 22. Got it?
Yes, sir.
So like this, we can understand slash notation actually. Clear everyone?
Yes.
Yes, sir.
I have one question. Cisco exam question. 50 marks question.
Okay.
255 dot 255 dot
Hmm.
230.0. So is it default subnet mask or is it customized subnet mask? Is it
Customize, sir.
CSM or CSM?
Customize.
Customize, sir. It's
Customize.
Okay. CSM or DSM?
uh,
Abdul,
Yes.
Ali Asgar,
Yes, sir.
Akid. Is CSM or DSM? Murphy, Raj Kumar,
Yes, sir.
Yes, sir.
Sham, Srikant, Tarun, Tomiwa, Murphy. CSM, right?
Yes.
Yes,
So it is not a DSM actually. It is not a DSM. Even it is not a CSM. The subnet mask is
invalid.
invalid.
how
Because Subnet mask, only the possible values are 128, 192, 224, 240, 248, 252, 254, 255. These only the values you can get in subnet mask. There is no other values from this value section.
Okay.
If you take any slash notation, you can get this combination only. See, after /8, when it started with /9, /10, see, we got repeated same values 128, 192. Got it? What are the
Yeah.
128, 192? Again, you'll get 224, 240, 240, same values.
Yes, sir.
In
Yes.
third octet also same values. In fourth octet also same values.
Okay.
Then how 230 can possible?
Invalid, sir.
Is invalid.
Invalid.
So subnet mask is only the possible values are these values only. So if you remember these values is good enough. Got it?
Clear, sir.
Okay.
Yeah. So finally, let us conclude for this today's session. Two major questions. One is, what is subnetting and why subnetting? What is subnetting? Creating multiple independent network from a single network, right?
Right, sir.
And why subnetting? To minimize the wastage of
Yeah.
IP addresses.
IP address.
Instead of wasting large number, 800 plus IP address, the IP minimizes IP address wastage can be minimized by using a subnetting process actually.
Yes, sir.
Yeah. Any more doubts? So actually, before starting the dynamic routing protocol, I would like to explain the subnetting concept. That's why I have explained about subnetting. And yesterday we have done static routing, and tomorrow we'll continue with the dynamic routing. I requested, so today you don't have any labs now. So I requested everyone, please practice on the static routing. Yesterday, if you have any pending labs. And one more task is make a few points about static routing advantages and disadvantages. Based upon yesterday discussions, you just write at least 2-3 points. Don't search in anywhere actually. If you search in the Google, you'll get a course, right? But based on your understanding, you just make your own notes, static routing. If you use static routing, what any advantages in or any drawbacks. So make a few points, at least 2-3 points you can write it. Anyhow, tomorrow I'll explain about this difference between static and dynamic routing. This is a task for you.
Okay, right, sir.
Okay.
Yeah. Thank you. Have a good day.
Thank you, sir.
Thank you, sir.
Hello, sir. Hello.
Yes.
Sir, can you please talk to me for 2 or 3 minutes? I have some question like I want to do live practicals. How can I get experience like live practicals get?